hopefully you remember that the square root of 150 is between two perfect squares that will give you the integer value. So below 150 we have 144. The square root of 144 is 12, which means above 150 we're going to end up with 13, which is the square root of 169. Now, square root of 150 is going to fall between these two values. We don't know exactly where yet, but we're going to determine that. And we do that by making a ratio. Now, let's start with what we know. We know that our solution is going to have a whole value of 12. Because remember, we're sitting on a number line. 13 is here on the number line. 12 is here on the number line. And our value that we're looking for is somewhere in between. So when we're creating our number must be 12 point something. We're looking for the fraction that this root 150 is in between root 144 and root 169. And so we're going to do that by calculating the part out of the whole. That's how we create any fraction. So in order to create the part, we need 150 minus 144, which is going to give us 6. And we need the whole, which is 169 minus 144, which is going to give us 25. Now, we want to take 6 and divide it by 25 so that we can find our decimal equivalence, and that equals 0.24. Well, since our part is equivalent to 0.24, we can say that 12.24 is our approximate value for the square root of 150. Now, if you plug it into the calculator, you're going to see 12.247 is the actual calculated solution. Had you rounded that, you would have ended up with 12.25, so I would have known if you had used a calculator versus calculating this by hand. I need for you to be aware of how to calculate this by hand. All right, pre-assessment. Pause the video, take just a minute to answer the following questions. 4 squared, 16, 3 squared, 9, 1 to the 4th power, not 3 squared, 3 cubed, 27. 1 to the 4th power would be 1 times 1 times 1 times 1, that's 4. 15 squared, 225. And 9 cubed is going to give us 729. Now this should all be a review of what we should already know with exponent laws, because in elementary your first introduction to exponents would have been expanded form, writing that out as 4 times 4. Writing this out as 3 times 3 times 3. Writing this out as 1 times 1 times 1 times 1. 15 times 15. 9 times 9 times 9. Now that we're in middle school, we just do it a little bit more intuitively. We don't need to write it out. We just know that 9 cubed is 9 times 9 times 9. Now 9 cubed is also one of the 1 through 10 cubes that are beneficial for you knowing next year. Right now we're working on the squares that you should know by Christmas. And then when we come back from Christmas, we're going to start assessing on the squares, and you're going to start working on memorizing the cubes. If you want to jumpstart on that, you can go ahead and start working on your cubes 1 through 10. So, what about a number raised to the 0th power? Let's complete the table below and see if we can see a pattern that helps us figure out what's going on. So, we have 3 to the 4th power. And 3 to the 4th power is 3 times 3 times 3 times 3. And that equals 81. 3 to the 3rd power is 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. 3 squared, well, we know that to be 9. 3 to the 1st power, that's 3. and 3 to the 0th power. Well, let's look at our pattern and see what's happening. 81 divided by 3 gives us 27. 27 divided by 3 gives us 9. 9 divided by 3 gives us 3. Well, if we follow the pattern, we should end up with 3 dividing by 3, which gives us 1. All right. So this is your power proof. This helps us to understand what 3 to the 0th power is as a solution in a logical method. Something about exponents. X to the cubed, we already know, is x times x times x. X squared is x times x. X to the first power is x. And so x to the 0th power is 1. What does this mean? This basically means anything you put in for that value of x, if it is raised to the 0th power, is going to be 1. It doesn't matter what value you put in there. You could put in infinity raised to the 0th power, and it's still going to equal 1. Simplifying exponential expressions. An exponential expression is completely simplified if there are no negative exponents. You cannot have a negative exponent. I'm going to show you how to get rid of the negative exponent in a moment here. The same base does not appear more than once in a product or quotient. Notice, I have x squared repeated. If this problem were simplified, I would only have one x base in the solution. No powers are raised to powers. Now, this could certainly be cleaned up. I'm going to show you how. No products are raised to powers. No quotients are raised to powers. And numerical coefficients in a quotient do not have any common factors other than 1. So notice 10 and 2 can be simplified. 2 goes into 2 one time, 2 goes into 10 5 times. So years ago, we learned that multiplication is an easier way to show repeated addition. For example, 2 plus 2 plus 2. Well, we can use multiplication. We can just say 2 times 4. Writing numbers in exponential form is just an easier way to show repeated multiplication. For example, 2 times 2 times 2 times 2 is equal to, well, how many 2's are shown? There's 4 2's shown, so 2 to the 4th power. Now, we could definitely simplify 2 to the 4th power because we know what 2 times 2 is. 2 times 2 is 4, times 2 more is 8, times 2 more is 16. So we could simplify this a little bit further because our base is 2. Vocabulary. Base exponent. An exponent tells us how many times a number, called the base, is multiplied by itself. So our base is always the value that has an exponential power. An exponential power is always that little subscripted number that is evidenced or visible on an integer or on a number. Now, I say evidenced or visible, but there are some that are not visible. For example, if I write the number 3 on the screen, it still has a power. It's just a known 1. We've dealt with known ones before. We do it all the time. If I write x plus 2x, we know that that x is a known 1x, so that we add 1x and 2x, we get 3x. So this is not really a new concept. 3 squared means 3 is multiplied by itself 2 times. So 3 squared is multiplied. 3 is multiplied by itself 2 times. It's equal to 3 times 3, which is equal to 9. 3 squared is not equal to 3 times 2. And I'm going to go ahead and tell you this is a very, very common mistake that I still see even in high school students. they rush through a problem, they see the 3 and the 2, and they go ahead and multiply. Please do not let that be a mistake that you make. Reading exponents. 4 to the 6th power is read 4 to the 6th power. 5 with the little 1 is read 5 to the 1st power. 3 with the little 8 is read 3 to the 8th power, and so on. There are 2 specifically named powers. These are 3 to the 2nd power, which we say 3 squared, or 4 to the 3rd power, which we say 4 cubed. So squared and cubed often are called by their alternative names. You don't tend to hear as commonly 3 to the 2nd power. It's not incorrect to say, it's just not as common. So we want to write each in exponential form. So 2 times 2 times 2 times 2, well, that would be equivalent to us saying 2 to the 4th power, which is equal to 16. 7 times 7, that's 7 squared, which is equal to 49. Let's go ahead and see if you can finish the last 3. All right, welcome back. We got 1, and there's 4 of them, so we have 1 to the 4th power. Well, 1 times anything is itself, and we're multiplying it by 1, so it's not really going to change our solution. 1 times 1 times 1 times 1 is 4. We have 3 5s, so we'll have 5 to the 3rd power is equal to 125. All right, this one seems to be a little bit different. Well, we have 2 times 2. Well, I could think logically and know that that's 4. And we had 3 times 3. I could think logically and know that that's 9. But we want to write it in exponential form first. So how many 2's do I have? I've got 2 2's. How many 3's do I have? We also have 2 3's. So notice we will end up with 2 squared times 3 squared, which does eventually simplify as far as the expression is concerned to 36. Write each as a repeated multiplication in expanded form and then find the value. So 3 squared, that'll give us 3 times 3, which is equal to 9. 3 cubed would be 3 times 3 times 3. That's equal to 27. 10 to the 1st power, well, we already talked about how that 1st power is really kind of an invisible. You don't tend to see numbers written in the 1st power. They're just known to be in the 1st power. So that we would simply say 10. And 2 to the 5th power, that's 5 2's getting multiplied together, which equals 32. All right, looks like I duplicated my power rule, or 0 power rule. So just for your reference, you can see it again. Notice that as we continue to divide each by 3, we get down to having 3 divided by 3, which gives us 1. So 3 to the 0th power is 1. Now, what about a number raised to the power? 1 times 10 to the 4th. Interesting thing to notice in this. Take just a minute and look at the slide. See if you can see a pattern with the scientific notation versus the integer notation. Well, this is an interesting problem. We're multiplying by 1 times a base 10 exponent. And we have a base 10 exponent here that has a 4th power. Notice how many zeros I end up in my solution. Well, that's interesting. 10 to the 3rd power, 3 zeros. 10 squared, 2 zeros. 10 to the 1st power, 1 0. And then 10 to the 0th power, as we continue to reduce the quantity of zeros, naturally we take away that last 0 and it would still be 1. It's just another proof that proves anything to the 0th power is equal to 1. All right, so any number 2 to the 0th power is equal to 1. 4 to the 0th power is equal to 1. 1 million to the 0th power is equal to 1. Negative 2 to the 0th power is equal to 1. Let's write it that way. I'll explain why later in the unit. Properties of exponents. A power raised to another power equals that base raised to the product of the exponents. So, for example, a to the m raised to the nth power is equal to a to the mnth power. Now let's look at some examples. For example, we have negative 3x squared is equal to negative 3 squared times x squared, which is equal to 9x squared. Well, you guys say, but Mr. Gable, that doesn't appear to be power to power. I only see one power. That is true, but we have to remember every number has a power. Whether you see it or you don't see it, it's there. So these terms inside the parentheses both have a power of 1. So we're saying negative 3 raised to the first power, raised to the second power. And so my 1 times 2 get multiplied and added as a power for negative 3. Again, our 1 times 2 get multiplied and added as a power to x. So that ends up with negative 3 times negative 3, which is 9, x times x, which is x squared. All right, this problem's a little bit different. I mean, it appears identical, but it's a little bit different. Notice on this particular problem, the negative sign is outside the parentheses. Well, our order of operations dictates that we solve everything in the parentheses first. And then we deal with exponents. Well, the exponents directly relate to the parentheses, but both of those take place before we have to worry about multiplying by negative 1. Yes, anytime you have a negative outside of a parentheses, it's probably a good idea to go ahead and write a 1 right next to it, just so that you remember there is a numeric value outside those parentheses. It's negative 1. Well, here we'll see that we have a 3 to the first power times x to the first power. And so we want to first apply our power rule. Power to power would be 1 times 2 is 2. 1 times 2 is 2. And now we can see I have negative 3 squared times x squared. Okay, but Mr. Gable, why do you have a negative 9? I thought we just said that negative 3 squared was 9. It is. Negative 3 squared is 9, and negative 3 squared is negative 9. It depends on what you're actually squaring. It's really hard to catch in the verbiage because up here we say negative 3 squared, and we mean negative 3 times negative 3 because the negative 3 itself, the entire value is getting squared. Now, in the lower problem, we say negative 3 squared, but what we mean is negative times 3 squared. And the only big difference is the location or presence of these parentheses. So on the bottom equation, we are saying 3 gets squared and then the negative sign gets added. On the top equation, we have the negative 3 as a number that is getting multiplied by itself, negative 3. It's a little nuance. It'll take you a little bit of time to get used to, but you're going to notice this even in your calculator. When you start plugging in solutions, if you're not very careful to put a negative value inside a parentheses, you will often get a wrong answer. 2 times 4 cubed. Now, you certainly have the option of multiplying inside the parentheses. You could say 2 times 4 is 8. And 8 cubed is equivalent to 8 times 8 times 8, which will be 512. Alternatively, we can recognize that there are 2 values inside the parentheses. We can use our power to power rule to say 2 to the first raised to the third power would be 2 to the third. 4 to the first raised to the third power would be 4 to the third. And that then gives us the ability to simplify each statement. 2 times 2 times 2 is 8. 4 to the third power is 64. And 8 times 64 is 512. That is the power to power rule. Next rule. Oh, sorry, not next rule. Time for us to practice these rules. So we have x to the third power raised to the fourth power. I want you to take just a moment and see if you can simplify that. All right, we have a power to the power, which means we're multiplying, so we should end up with x to the 12th power. Okay, naturally they're not all going to be that easy, so we need to be able to do them as they get a little bit more complex. Pause the video, give this one a try, and then come back and watch the video and see how you did. All right, here we go. So we have 2 to the first power, but it's outside the parentheses, so nothing is happening with it. So we will leave it down there as 2 because there's nothing else influencing its power. We have x to the third raised to the third power, so I know I'm going to multiply the powers. X to the 9th plus. Well, this problem is now very different on the right side. I have 2x to the third power, but 2 with its first power is inside the parentheses, and 3 with, x with its third power is inside the parentheses. So we are going to have a power to power rule that needs to apply to both of those values inside the parentheses. So 2 to the first times 3, it would be 2 to the third power. X to the third times 3 would be x to the 9th power. Well, this can certainly be cleaned up. So we're going to end up with 2x to the 9th power plus 2 to the third power. 2 times 2 is 4 times 2 is 8. X to the 9th power. And now we would see that we have common bases. And both of them have the same power, so they're like terms. 2x to the 9th and 8x to the 9th gives me 10x to the 9th. All right, let's try one more. Just a little bit more complicated. See if you can figure out the solution. Negative 3x squared plus 2 to the first power squared would be 2 to the second power. X to the first power squared would be x to the second power equals 49. All right, negative 3x squared plus 4x squared is equal to 49. We haven't quite simplified the equation. Yes, it does say no, you do not have to solve. Let's finish simplifying. Negative 3x squared plus 4x squared gives me x squared equals 49. Now, you certainly don't have to solve, but we could, couldn't we? We solved these this past Wednesday. You take the square root of both sides, and x is equal to plus or minus 7. Negative exponents. Negative exponents in the numerator get moved to the denominator and become positive exponents. Negative exponents in the denominator get moved to the numerator and become positive exponents. Now, I often talk about having a little brother or sister that really gets annoying to you. Oops. So, if we have x to the negative mth power, and that negative m is our annoying brother, and you would like for that annoying brother to not be around you anymore, you need to tell them to go to the basement. And so if we send them to the basement, we have x to the mth power because the power now changes, and you are in a much better mood, and they are in a much better mood because you're no longer around each other to be annoyed. Now, the same is true if you were down in the basement and you were a negative power. You could go upstairs to become positive and happy and have a positive power. So these tend to be your blanket examples. X to the negative mth. In order to make the m positive, again, we bring it down into the denominator, and it changes the exponential power to its opposite. Over here on the right, we have 1 over x to the negative mth. In order to make the negative m positive, we move the entire term up, and the power becomes positive. So let's see if we can try one of these together. X to the negative second. In order to make it positive, we need to bring the power down into the basement. What's left in the numerator? Well, nothing's left in the numerator, so we have to put in the filler 1. Let's see if you can try the next two. All right, welcome back. Again, we have a negative power, so we're going to bring the power and its base up into the numerator. X to the fourth divided by, well, all we have left down here in the denominator is 1. Well, anything over 1 is simply itself, so x to the fourth power. Number 3, again, we have a negative attitude, so we want to bring it up into the numerator. X to the third power over 1 is equal to 8. So we are asking ourselves what number, when we multiply it by itself 2 additional times, will equal 8. And since this is a term that you're going to work on memorizing, I'll go ahead and give it to you. 2 is equal to x. Now, eventually you'll get to the point where you realize, hey, I have a third power. I can take a cubed root. What I do to one side of the equation, I have to do to both sides. The cubed root of x cubed, just like with square root, we're looking for pairs. With cubed roots, we're looking for triples. And so I have 3 x's, so I would be able to pull the 1 out. And we would be trying to figure out what factor triples could be made out of 8. So we could certainly break 8 down into its factors, 4 and 2, where 4 breaks down into 2 and 2, and we see that we have triple 2's. And so the cubed root of 8 would be 2. All right, let's try a slightly messier one. I want you to first give it a try, and then come back and check the answer. All right, welcome back. So we have negative 3 to the first power times x to the negative second power. Well, in order for it to be positive, we've got to move something to the denominator. Notice, however, that the 1 is positive, even though the 3 has a negative sign in front of it. So we have the term negative 1 raised to the positive first power. That means it already has a positive exponential power. It can stay upstairs and still be happy. The only thing that needs to move downstairs is this negative 2 and its base. And so in order to make the base happy, we're going to take it downstairs, and it will become x squared. We will add to that. Now, the right side of this expression is a little bit different. We're going to be reapplying our power to power rule. And so we have 2 to the first power raised to the negative second. That's 2 to the negative second power. We have x to the first power raised to the negative second. So that's x to the negative second. And we want both of these terms to be happy. So we're going to put both of those terms into the denominator to make them happy. 2 squared x, oh wait, why did you do that? 2 squared x squared. Well, what's left in the numerator for this particular ratio? Nothing's left, so we fill it with the 1. All right, over here, we have 49 to the negative first power. Well, in order to make 49 happy, we've got to bring that entire term up in the numerator with its base. So we'll end up with 2 times 49. All right, this one does say not to solve. It applies some math that's a little bit higher, so we're not going to go through this one completely, but we will finish simplifying. Negative 3 over x squared plus 1 over 2 squared, which is 4x squared, is equal to 2 times 49, which is 98. And that satisfies the directions. We're going to stop there so we can keep moving on with more fun stuff. Have a fun day.